Welcome to a fascinating journey through the cosmos. Scientists are still afraid of this star, Wolf-Rayet. It could destroy Earth at any moment. Wolf-Rayet stars, a rare and extraordinary class of celestial bodies that are crucial to our understanding of stellar evolution. Wolf-Rayet stars, or WR stars, are unique for their unusual spectra. They show broad emission lines of ionized helium and highly ionized nitrogen or carbon. These spectral features suggest very high surface temperatures, ranging from 20,000 K to about 210,000 K. That's hotter than most other stars in our universe. Typically, these stars have lost their outer hydrogen layers and are burning helium or even heavier elements in their cores. Young examples of WR stars, known as WNH stars, still fuse hydrogen at their cores. As these massive stars evolve, they expose helium and nitrogen at their surfaces due to radiation-driven mass loss. Despite their incredible luminosity, way more than 1 million times that of our Sun, they aren't prominently bright because most of their light is emitted in the ultraviolet spectrum. Historically, Wolf-Rayet stars were first identified in 1867, leading to decades of investigation into what made them so unique. The initial confusion about their nature was eventually dispelled in the mid-20th century, as researchers began linking their spectra to different types of star evolution. Often, we see them associated with planetary nebulae, as some serve as central stars in these formations. Moreover, features in their spectra indicate they are surrounded by fast-moving gas, with speeds reaching up to 2,400 kilometers per second, expelled into space. The classification of Wolf-Rayet stars has developed significantly over the years. They are mainly categorized into 3 classes by their spectral emission lines: WN stars, which are dominated by nitrogen; WC stars, which are carbon-rich; and WO stars, which are evolving from carbon-burning stages. As we explore different WR stars, we encounter the extreme case of the star R13601, dubbed the most massive star known, still within its prime hydrogen-burning stage. In many cases, the presence of WR stars hints at ongoing massive star formation. This connectivity to stellar formation means they can act as indicators of young stellar populations in galaxies, particularly in starburst regions. Various Wolf-Rayet galaxies show WN signatures, emphasizing their role in understanding galaxy formation and evolution. These galaxies exhibit characteristic emission line features due to numerous WR stars, reflective of recent bursts of star formation. Recent studies have revealed that binary interactions amongst stars can lead to additional mechanisms driving the evolution of Wolf-Rayet stars. These interactions help explain some of the peculiar spectral types we observe. Looking to the future, astronomers are excited to discover more about WR stars, especially their role as progenitors of certain types of supernovae. Studies suggest that WR stars might explode dramatically when they reach a particular evolutionary stage, often identified in type IB or IC supernovae. So, will you join us in further exploring the cosmic wonders? Dive deeper into the magnificent world of Wolf-Rayet stars and continue your celestial adventure today. Your journey through the stars awaits. This is an image of a distant galaxy, about 45 million light-years from Earth. The Hubble telescope took this image. If you look closely, you'll see that it's different from our Milky Way and Andromeda galaxies. It appears to be soaring into space, with stars in its wake. At first glance, it might look ordinary, but it's a very special galaxy. The stars that make it up are very bright and powerful, and they are helping scientists learn new things about the growth and transformation of galaxies. You've never heard of this? These stars are much, much bigger than our Sun. They're so bright that thousands of suns combined wouldn't be that bright. But these enormous stars are also outraged. If anything gets too close, like a human or even an alien spacecraft, the star will be destroyed. Not even the most advanced aliens will be safe. These stars aren't afraid of anything, they're so powerful. Scientists are even a little fearful of them. Do you know what these stars are called? If one of them decides to use all its power at once, it can become brighter than the entire galaxy and change everything around it. A long time ago, in the year 1867, two astronomers named Charles Wolf and Georges Rayet were looking at the stars through a telescope in Paris. When they looked at a group of stars called the Cygnus constellation, they saw three stars that looked a little different. They studied the light from these stars to learn more about them. By observing a star's light, scientists can discover amazing things. They can determine its brightness and mass, as well as the materials, called elements, it contains. When a telescope collects a star's light, it uses a special instrument called a spectrometer to separate the light into multiple colors, like a rainbow. Within this rainbow, there are dark lines that look like the star's fingerprint. By observing these dark lines, scientists can determine what elements the star contains and how much of each. For example, our Sun is made of two things, about 70% hydrogen and 28% helium. We learn a lot about stars by looking at their light. About 150 years ago, two scientists named Charles Wolf and Georges Rayet saw three special stars from a place called the Paris Observatory. They noticed that these stars looked very different from our Sun. The Sun's light has dark lines in it, kind of like stripes. But these stars didn't have dark lines at all. Instead, they had bright red lines on a dark background. These bright lines are called emission lines. Some dark lines, called absorption lines, are special marks seen when we look at stars. Two scientists named Charles Wolf and Georges Rayet found that some stars have lots of bright lines instead. These bright lines only show up in very hot and bright stars that are super hot, hot enough to be hundreds of thousands of degrees Celsius. Because of these stars, they are called Wolf-Rayet stars, named after the scientists. Now, let's learn more about how big and hot these stars are. There's one such star about 8,000 light-years away from us, in a part of the sky called the Cassiopeia constellation. There's a bright star in the sky, so bright that it may outshine hundreds of thousands of suns combined. Scientists call it deadliest AR, which is another name for a special type of star called a Wolf-Rayet star. Although deadliest AR is slightly smaller than our Sun, about 10% smaller, it's much heavier, about 16 times heavier than the Sun. Its surface is extremely hot, about 26 times hotter than the Sun's surface. The Sun's surface is around 5,500 degrees Celsius, but deadliest's surface reaches 140,000 degrees Celsius. It's also incredibly bright, about 282,000 times brighter than our Sun. There's a super dangerous type of energy called radiation that emanates from the front of a star. This energy is so intense that it can pass through any object in its path. If you're traveling in a normal spacecraft, there's no way to escape this blast. You need a special shield to protect yourself from the powerful X-rays and gamma rays. This star is, in fact, the smallest of a group called Wolf-Rayet stars. Although it's tiny, it's much heavier than our Sun. Think about it. If this tiny star can cause trouble for the Sun, the larger Wolf-Rayet star must be incredibly strong and powerful. Let's imagine we're traveling far, far away, about 163,000 light-years from Earth, to a small galaxy called the Large Magellanic Cloud, which is close to our galaxy, the Milky Way. In that galaxy, there's a huge cloud of gas and dust called a nebula, and it's the biggest one in the universe, so big it stretches across 1,800 light-years. Right in the middle of this nebula, there's a special star called R13601. It's the brightest and heaviest star we know of, so big that it's 200 times wider than our Sun and much more spread out. This star is like a giant glowing beast in the sky. Let's imagine we travel very far away, about 163,000 light-years from Earth, to a small galaxy called the Large Magellanic Cloud, close to our own galaxy, the Milky Way. In that galaxy, there is a huge cloud of gas and dust called a nebula, the largest in the universe, so large that it stretches across 1,800 light-years. Right in the middle of this nebula lies a special star called R13601. It is the brightest and heaviest star we know of, so large that it is 200 times wider than our Sun and much more extended. This star is like a gigantic, shining beast in the sky. It's not going to happen. If star 36 approaches our neighbor, Proxima Centauri, 4 light-years away, it will appear as big as our moon in the sky. It will look like there are 2 moons up there. But because of its great brightness, we will no longer be able to see many of the other stars in the night sky. The brighter a special type of star, called a Wolf-Rayet star, is, the faster it will dim and stop shining. This type of star is extremely hot on its exterior and emits strong beams of energy. These beams cause powerful winds that expel particles such as tiny protons and electrons. There is a star called star 36. The wind, which is like a strong breeze coming off the star, blows very fast, at 2,600 kilometers per second. Because of this fast wind, the star loses a lot of its weight every year, about 3 billion kilograms. To imagine that, it would take the Sun millions of years to lose the same amount of weight. Since the star keeps losing so much mass so quickly, it won't last forever and will eventually disappear. When the star finally explodes in a huge explosion called a supernova, it releases a lot of energy, like a giant burst of light and heat. If there are planets or other space objects near it, within 100 light-years, the explosion could strip away their atmospheres or even destroy them completely. Imagine there could be planets or aliens somewhere in space. But if they were near a special kind of star called a Wolf-Rayet star, they probably wouldn't survive. That's because this star emits super powerful energy called gamma rays, which can destroy planets and make it impossible for any living thing to survive. Currently, this star isn't even in the same galaxy as us, so we shouldn't worry. But one day, when this star finally explodes in a huge explosion called a supernova, people in the future will be able to watch it shine for thousands of years. And if you think there aren't any of these huge Wolf-Rayet stars in our galaxy, you're wrong. They are. Imagine that this star emits super powerful energy called gamma rays, which can destroy planets and make it impossible for any living thing to survive. Currently, this star isn't even in the same galaxy as us, so we shouldn't worry. But one day, when this star finally explodes in a huge explosion called a supernova, people in the future will be able to watch it shine for thousands of years. And if you think there aren't any of these huge Wolf-Rayet stars in our galaxy, you're wrong. They are. If it moves closer to Earth, then 8,000 years after the explosion, our planet will face deadly radiation. This could wipe out all life on Earth. But scientists say this star is so far away that the radiation won't have much effect on our planet. So, we might survive it. What happens in the future, though? Only time will tell. So, friends, I hope you learned a lot of new stuff from today's video. If any of the info was totally new to you, be sure to let me know in the comments. Thanks.
Welcome to our channel. Disclaimer: this channel does not promote any illegal activities, and all contents in this channel is for educational purposes only. Our channel based videos promoting for educational tutorials, famous quotes of the world, biological, historical and geographical facts, genius stories and biography. Please follow or subscribe the channel and press the bell icon for more videos. Thank you.